Welcome to my video. For my final year design project, I've designed a flow meter which will measure the amount of biogas being produced from an anaerobic bench scale digester. On the left is the anaerobic digester and on the right is the flow meter. Anaerobic digestion is the breakdown of organic material by bacteria to produce biogas. Biogas consists of approximately 60% methane and 40% carbon dioxide, and it is the methane that we are interested in. Once the gas is produced, it can be upgraded and sold back into the national gas grid. It can be used to generate electricity, which can be sold back into the electricity grid, or it can be used to produce vehicle transport fuel. As we zoom in on the anaerobic digester, we see a condenser. This is to cool down the anaerobic digestion process if necessary. The two pipes protruding from the cylinder are connected to an external control. All of the pipes here are connected to an external control. This is a nitrogen flusher which flushes nitrogen through the system before the anaerobic digestion takes place in order to ensure that no oxygen is in the system, hence anaerobic. Here we can see hot water input and water output, again for temperature control. Because this is a continuously stirred tank reactor or CSTR, there is a motor which propels two paddles at the bottom. As the camera moves down the shafts, we can see two of the paddles at the bottom which continuously stir to stir the organic material in the anaerobic digester. In reality, there's actually 8 paddles. As the camera swings around, we can see the biogas exhaust pipe coming from the top of the anaerobic digester. As the gas is created, it moves up along this pipe and out. It then enters the tip flow meter from the bottom of the tank. The bucket is submerged in water, and as the gas bubbles up through the bottom of the tank, it is forced into the cavity that we can see clearly here. The biogas congregates here in the cavity until such time that the upward pressure of the gas exerts enough force to tip the bucket over. The bucket will tip along the axis as seen on the right, from left to right. Here we can see a block which prevents the bucket from over-rotating, on which is mounted a magnet. This will hold the bucket in place until such time that there is enough gas to ensure the bucket will tip all the way over. Another magnet is placed on the side here. As the bucket tips, this magnet will follow the path drawn out, the arc, and pass an electric copper coil. As the magnet passes the copper coil, a small electric current is generated. This current passes along the green wire, which is attached to a computer. Every time the bucket tips, a current is generated and the computer records it. When the bucket tips, it releases the gas into the headspace and the gas exits out this yellow tube. The gas then passes along the yellow tube and into biogas storage bags, seen in the red colour here. These biogas storage bags come in many different shapes and sizes. They are very economical and they're the best way of storing biogas. Everything you can see in the diagram here is to scale, bar the diameter of the pipes, which in reality is probably a good bit smaller. Thanks for taking the time to watch the video. I hope this clears up anything that was previously unclear.